Hello, good day. Welcome to today's class. So I want us to look at Faraday's first law of electrolysis in chemistry. So what is Faraday's first law of electrolysis? It states that the mass of an element deposited at the electrode. If for example, you are carrying out this particular experiment. 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 So this is plus negative. This is anode. This is cathode. So let's say you have NaCl aqueous. Now this NaCl will be ionized to Na plus, Cl minus, and H plus, OH minus. So the mass of an element, that is mass of Na, or mass of H plus, or mass of Cl minus, or mass of oxygen that will be deposited at the electrode, either cathode or anode, is directly proportional to the quantity of electricity passing through the electrolyte. So what this one is saying is telling us that the amount of Na that will be produced will be determined by the quantity of electricity passing through these electrolytes, which is Na. So the more the electricity, the more amount of the element will be deposited at various electrodes. So that's what this law is telling us. So from that we can derive a formula from that law that says the mass of an element is directly proportional to the Q. Therefore, M is equal to KQ, and Q, since Q is equal to IT, that is current times time, then we have M is equal to KIT. Then this K now is equal to Z, so we have M, so ZIT. So that Z is called chemical equivalent. So it's chemical equivalent. So then we now move to Faraday mass-mole relationship. Faraday mass-mole relationship. Faraday mass-mole relationship. Faraday mass-mole relationship. The first one for monovalent metal, e.g. Na plus. So this one is monovalent, it's having one valency, one charge. So in that case, if you want to write the equation, this is it. So that means you write 1 farad equals 1 mole. 1 farad equals 1 mole. 1 farad equals 1 mole. Then the E minus is equal to 1. So take note of these two. 1 farad equals 1 mole. For divalent metal, So the valence meter Eg Zn2 plus 2 farad will be equal to 1 mole. Then the E minus is equal to what? 2. Then the third one for trivalent meter Eg Al3 plus. So it will be 3 farad equal to 1 mole. Then the E minus will be what? It will be 3. So I hope it's clear. So if you have any question, you can ask in the comment section. So the next one is for oxygen. For oxygen, you know, oxygen is produced when OH is discharged in electrolysis. So you have four O, you know, so we can still remember 4 OH minus to give us 2H2O plus O2 plus 4E minus. You know, when OH is discharged, gives us OH plus E minus. Then when this OH is unstable, this I'm just showing how everything is being gotten. So this OH is unstable. So OH we have another OH to give us H2O plus O. Likewise, that oxygen too is not stable as well. So you come out with another oxygen to give us the O2. So that's how it goes. So this is the reaction. So you can see that it is 4 E minus, so it is 4. So in that case, it will be 4 farad. 4 farad equals what? Equals 1 mole. So the E minus of oxygen will be 4. So that's that. So we took on that. Now for hydrogen. For hydrogen and chlorine. For hydrogen and chlorine. So to solve this particular electrolytic question, let's say a current of 4 ampere was passed through copper 2 tetravalent solution for 1 hour. Calculate the mass and calculate the quantity of electricity packs and the mole of copper deposited. I want to give you a very short formula that you can just apply directly and substitute to the question. So the first formula is this. So let's talk about that formula first before we come back to this calculation. So mass is equal to Q times RAM over E minus times 96500. So you can note this formula down. Note it down. And this formula, we can also write it like this. You know, this is RAM, relative atomic mass. So you can also write the formula like mass over RAM, which is equal to Q over E minus times 96500. And so mass over RAM is what is mole. So mole is equal to Q over E minus times 96500. And what is Q? So you can say mole now is equal to I multiplied by T by E minus times 96500. So this formula now, so it's very important. It depends on what we have to find. Like this question, they have to find mole. So we can easily apply this particular formula to get the mole straight away. If they have to calculate mass, you can apply this one. And don't forget the Q is IT, so it's just replace Q with IT. Then you get your mass, or you have to find relative atomic mass, or even you have to find E minus. So any parameters you have to find. So you see the formula there. This one, this is same thing. I just rearrange, but yeah, I've replaced this mass over RAM with mole because mole is also what mass over relative atomic mass. So that's that. But if it is volume, let's assume maybe another question they ask to find volume. So if it is volume, so it will be volume is equal to Q times molar volume, which is 22.4 dm cube over E minus times 96500. So if it is volume, you apply this. if it's mass, you apply this. So because Q is IT. So but if it is mole for any of them, either it is gas or for any for mole, for always you apply this one. So take note of the formula. So now for us to solve this question now, let's come back for us to solve this question now. So let's see, for us to solve this question now. So you have to find Q first. So Q is equal to I times T. So what is I? What is I in the question? I is equal to 4 ampere. 4A. What is T? T is 1 hour. So 1 hour, which is 1 times 60 times 60. So that's 3,000. 6 times 6, yes, 3,600 seconds. So Q now will now be equal to 4 times 3,600. So press your calculator. So what is 4 times 3,600? So you can just press your calculator and give us that answer. 4 times 3,600. So that is 14,400 coulomb. So now the next question says you should find the mole, and I've given you the formula to find mole. And the formula is a mole equals to I times T over E minus times 96500. So that will be, what is I times T? This is 14,400. This is A. This is B. So what is E minus? Okay, you know, they are talking about copper, and copper is Cu2 plus 2E minus to give us the Cu. And I told you copper is a divalent metal. If you can remember what I just explained. So on top of what I've explained, so the E minus will be 2. So the E minus is 2 and 96500. So let's solve it. Use calculator to solve that. It will be 14,400 over, so 2 times 96500. 96500, that is 193,000. 93,000. That's 96500. So that was the answer now. So 14,400 divided by 193,000. 3,000. So that is so the answer is 0.0746, and we are looking for mole. So the answer is mole. So second example. So a current of 0.20 ampere flowed through a silver trans-95 solution during an electrolytic process that lasted for 30 minutes. Calculate the mass of silver deposited. So like I told you before, it is the formula: mass equals Q times gram over E minus times 96500. So I is equal to, what is I? 0.208 times 30 minutes. Okay, 30 minutes. So which is 30 times 60. So that is 1,800 seconds. So Q now. Okay. Let's substitute into the. But before substitute, RAM. What is RAM? RAM is 108. Then what is E minus? Since they are talking about silver, that is Ag. So it will be Ag plus E minus to give Ag. So the E minus is 1. The E minus is 1. The E minus is 1. So let's substitute the formula now. So mass equals this Q is I times T times RAM over E minus times 96500. So that will be because of what is I? 0.20 times Okay, let me solve it here. What is I? 0.20 times T 1800 times 108, everything over 1 times 96500. So let's use calculator. Let's use the calculator to solve it. That will be 0.20 times 1800 times 108. So the answer that will be 3880 over 96500. So multiplication of this will give us this. So multiply that 38,880 divided by 96500. So that should be 0.4029. So they are approximately 0.403. So since we are looking for mass, so we need the gram. So that is the answer for that. The third example is 0.5 gram of divalent meter was deposited when a current of 0.45 ampere was passed through a solution of its salts for 30 minutes using appropriate electrodes. Calculate the relative atomic mass, that is RAM. So they're asking us to find RAM like that of the metal. So what are we given? Given mass to be 0.50 gram. We're given I to be 0.45 ampere. They were given time also to be 30 minutes. That is 180. Okay, so that is 30 times 60. 30 times 60. So that is 1800 seconds. So now, it is the element is not mentioned. It's a divalent meter. So since it is divalent meter, let's say Sp plus 2E minus, it will give us X. So the name of the meter is not mentioned, so I use X to represent it. So that means the E minus now is got 2. So the formula I gave you before, mass equals I times T times RAM over E minus times 96500. So if you make RAM the subject of formula, so it will be RAM is equal to mass times E minus times 96500 over I times T. So what is mass? Mass is 0.50. Okay. 0.50. Then what is E minus? I is 2. 96500. Then this I 0.45. This is T 1800. So you use your calculator. So 0.5 times 2 times 96500. So 0.5 times 2 is just like 1. So times 96500. This one is just like 1. So it will just give us 96500 over 0.45 times 1800. So 0.45 times 1800, that's 810. So 810. So you let divide now. 96500 divided by 810. So that is in the calculator. So I got 11919. So since it is relative atomic mass. So you don't need to put units. In science, most relatives don't usually have units. Relative density, no unit. Relative atomic mass, no unit. Relative molecular mass, no unit. So take note of that. So that is the answer for the question. The second law of electrolysis. Why the second law of electrolysis state that when the same quantity of electricity is passed through different electrolytes. So we have an electrolyte here, and that one is here, and that one is here. So they all arrange in series like this. You know what? Arrange in series. The same quantity of electricity will pass through them like this, pass through them like this, go like that. So arrange in series like this. So the amount in mole of each element liberated, maybe here copper is liberated, maybe here Pb is liberated, maybe here aluminum is liberated. So the amount in mole of each element liberated is inversely proportional. Is what? Inversely proportional to the charge of its ion. So like this one is C2 plus now, so 2 plus, this one is 3 plus. So what we are saying here is this. So this is what we are saying here, that the number of moles is inversely proportional to the charge. Is inversely proportional to the charge of the element liberated. So far, the same quantity of electricity is passed. So in that case, so it will not be K over C. So K is equal to what? NC. So for 2 or 3 cases, maybe 2 or 3 element, 3 solution arranged in series, or 2 or 3 elements be liberated. So we now have N1 C1 equal to N2 C2 equal to N3 C3. So it depends. So you can equate this one to this one to this, or this. So it depends. So it depends on the question. So this formula is very important. So the formula, let's take note of this formula for second law of electrolysis. First example on second law of electrolysis. So calculate the mass of lead that will be deposited from a solution of lead 2 triisonitrate 5 by the same quantity of electricity, depositing 1.35 gram of copper from a solution of copper 2 tetrasulfate 6. So from this question now, you discover that they are talking about 2 solutions, but same what? Same quantity of electricity. So the formula I gave you before is, you can remember, N1 C1 is equal to N2 C2, because this is just talking about 2 species. So you know what is mole? Mole is mass over RAM, mass over relative atomic mass. So in that case, so it will be mass over relative atomic mass of, so the first element is lead, so of lead Pb over charge of lead. This C here is charge. Then mass charge of lead. Maybe I should write the charge in full so that you can understand what I'm saying. Charge, let me write the charge in full. Charge of lead is equal to mass over RAM of copper Cu by charge of copper. So this is the formula we're going to apply. So what is the mass of lead? Mass of lead. So we are looking for it. So that is unknown. RAM of lead is 207. RAM of lead is 207 times charge of lead. You know, lead is Pb2 plus. Lead is Pb2 plus. Copper is C2 plus. So times 2. Mass of copper is given 1.35. Gram of copper is given 63.5 times charge of copper. That's 2. So these two will cancel these two. Or you can cross multiply. You can so we're looking for this mass. So these two will cancel these two. So we have M over 207 is equal to 1.35 over 63.5. So making M the surrogate of the formula, you have 1.35 times 207 over 63.5. So there is the calculator to solve it. Calculator. So that's then 1.35 times 207. So that's then 1.35 times 207. That's then 279.45 over 63.5. So what's the answer? Divided by 63.5. So the answer is 4.40. What are we looking for? Mass, gram. So 4.40 gram of lead. So that's, so you can see that it's very straightforward, very simple. There's nothing much. Just understand the formula and put it to the question and get the answer. So another example on second law of electrolysis. Let's see. In an electrolytic process, solution of CuSO4 and H2SO4 were electrolyzed in series. If 1.27 grams of copper was deposited, calculate the volume of oxygen liberated at STP. So the formula I gave you before, N1C1 is equal to N2C2. So what's the first thing they mention? So mention copper CuSO4. So that means that will be mass, that will be M over R of Cu, charge of Cu is equal to, the second one is H2SO4, and they are talking about oxygen. So that means it is oxygen that was liberated from here. So since oxygen is a gas and they have to find the volume, so we use this formula. No, another formula for mole is this: mole equals volume over molar volume at STP. So that's another formula for mole. So in that case, volume over molar volume of oxygen times charge of oxygen. So what is mass of copper now? Mass of copper. So we're given 1.27. So 1.27 over gram of copper is 3.5 times charge of copper is 2. So we have to find the volume of oxygen, that is V, we are looking for it. Molar volume at STP, that is in 22.4. As charge of oxygen, you can remember charge of oxygen is 4. So from this reaction, 4 OH minus to give H2O plus O2 plus 4 E minus, so it is 4. It is 4. So this will be 1.27 times 2 versus 3.5 is equal to 4V over 22.4. So let's make V the surrogate of the formula. So V now will be equal to, so multiply this one and this one and this will be at the up. So 1.27 times 2 times 22.4 over 4 times 63.5. So let's press the calculator and get the value out. So 1.27 times 2 times 22.4, that should be 56.896. So over, so 4 times 63 0.5, 60.5, that's then 25, 254. That is 254. So let's divide that. 56.896 divided by 254. So that is 0.224. So you know the value here is in GM cube. So we can make it in CM cube by multiply by 1000. So it will be 224 CM cube. So I hope it's clear. Alright, so let's talk about cost of production by electrolysis. So you also ask question on that area. Let's say if the cost of electricity to deposit 1.0 gram of magnesium is 5 naira, how much will it cost to deposit 10 gram of aluminium? So if you see this question like this, you try to look for quantity of electricity of magnesium, then quantity of electricity of the aluminium, then you now do correlation. So let's see. So there's a formula I gave you before. Mass equals Q times RAM over E minus times 96500. 96500. So for magnesium now, for magnesium, what is the mass of magnesium? 1. For magnesium, mass of magnesium is 1. 1. 1. So that means 1 is equal to Q times what is the RAM of magnesium? 24. E minus of magnesium is Mg2 plus 2E minus is Mg plus 2E minus to give Mg. So there is 2. So 2 times. So since we are looking for Q here, so let's make this 96500 to be 1 because 1 farad now is equal to 96500. So let's make the unit to be in farad. So this one will be times 1. So instead of already dealing with big value. So 2 here 1. So this will be 12. So this one here 1, 12 here 1, 12 here, and 2 here is 12. So we now have Q now. Q will now be equal to 1 over 12 farad. For aluminum now, the mass of aluminum is 10. So 10 equals Q times 20. No, it's 27. Sorry, this is 27, not 27. It's 27, not 27, it's 27. So Q times 27 over so D minus of aluminum. Aluminum is A3 plus 3 minus to give AL. So it's 3. So 3 times 1. So 3 here 1, 3 here 9. So Q now be okay. The Q for aluminum will now be 10 over 9 farad. So we can now say now 1 over 12 farad of magnesium is equal to 5 naira. So that means 10 over 9 farad of aluminum will be X. So let's cross multiply. So now correlate, now cross multiply. So that will be X over 12 is equal to 5 times 10 over 9. So X now will now be 5 times 10 times 12 over 9. So let's divide. Let's multiply and divide. 10 times 12. So that's 600 over 9. So divided by 9. So that's 66.67 naira. So that is the answer. So when you see this question in the exam, you look for find the Q of the first one, the Q of the second one, then you now correlate like this. Thank you.